Good morning, guys. So today we are moving on with chapter 5, and our lesson today is going to be on addition and subtraction of rational expressions and complex fractions. So before we get into the nitty-gritty of this, we just have to refresh ourselves with the rules of adding and subtracting fractions because we haven't done that in a while, probably since, I don't know, elementary school. And nowadays, we typically use our calculators a lot when we have to do that in a problem or something. So just to kind of review that. So the big thing here is that you must have the same denominator in order to add or subtract rational expressions. So yesterday we went over multiplying and dividing rational expressions. When we multiply and divide fractions or rational expressions, we just multiply the numerators, multiply the denominators, and it doesn't matter if they're the same or different. We just do the multiplication. But when we're adding or subtracting fractions or rational expressions, we need to have common denominators. So just to kind of review that skill with just some basic fractions back from elementary school, if we were going to subtract or add fractions that have different denominators, we would need to get them to be the same. Now, ideally, you want to do this by keeping them the smallest that they can be, so that's why it's called the least common denominator. So, like for 7 and 14, you could do 7 times 14 and get a common denominator, but that would be a very large number. I believe it would be 98. So that's kind of a bigger number than you're going to need to work with, and you'd have to simplify and all of that. So typically, we would want to come up with the least common denominator. So if you think about all the numbers that 7 go into and all the numbers that 14 go into, what is the smallest one that they both go into evenly? So in this particular problem, we can look at 7 and 14, and we know that 7 actually goes into 14 evenly. So all we would have to do is make 7 into a 14 as well. So in order to do that, we would have to multiply the 7 by 2. Now the rule is whatever you have to do to the bottom of the fraction, you must also do to the top. So both my 4 and 7 would get multiplied by 2, so that would give me 8 over 14. And then my other fraction would stay the same. And now, once you've got your common denominators, you just do the operation with the numerator. So 8 minus 1 would give me 7. Now, sometimes it happens that you can further simplify that fraction by reducing it. So 7 over 14 would simplify to 1/2. So now, if we are going to do the next problem with the 2/3 plus 4/5, this time, the two denominators are two separate numbers, but 3 does not fit into 5, so there's no multiple of 3 that equals 5. So you'd have to come up with the number that they both fit into. Now, in this particular case, if I'm listing my factors of 3, 3, 6, 9, 12, 15, and then I'm listing my factors of 5, so I'd have 5, 10, 15, 20, and so on. Obviously, we can see that the first one that we have in common, or the least common denominator, is 15. So in that case, I have to multiply my first fraction. The 3 needs to be multiplied by a 5 to get 15, which means I'm also going to multiply my 2 in the numerator by 5 as well. So then that gives me 10 over 15. The second fraction, in order to get a 15 on the bottom, I'd have to multiply that 5 by 3. So then the 4 in the numerator will also get multiplied by 3, giving me 12 over 15. Then I can do the operation, so addition or subtraction. This one's addition, so I have 22 over 15. Now, if that fraction could be simplified or reduced, I would have to do that, but 22 over 15 does not simplify any further. So hopefully that's just like a little refresher of addition and subtraction rules. So now we can use those when we are solving or adding and subtracting the rational expressions. Okay, so we're going to start out rather simple with just the common denominators already set up for us, just so we can see how it kind of applies with the binomials and things like that. So again, first thing we want to do is make sure that they have this common denominator. If they have the common denominator, you can just write that once, x minus 4, and now you can just sum up the top. So you're just going to do 3x plus 6. Okay, so now sometimes you might be done at that point, sometimes you might not be, it really depends. Now this brings us back to the beginning of yesterday's lesson where we had to simplify the rational expression. So if there's anything that can be factored or canceled, then we still have to do that. Just like in the last example that I gave you, we had gotten 7 over 14 and we had to simplify it to the 1/2. The same process would apply for the rational expressions when you have something that can be simplified. So the only way for you to really know if something can be simplified is to make sure that it's factored completely. So if you look at this numerator here, 3x plus 6, I can take out a GCF of 3, leaving me with x plus 2. Now, in this particular problem, this would be my final answer. Even though I factored out that GCF of 3, it didn't help me cancel anything. Sometimes it does, sometimes it doesn't. So you just need to factor it out to make sure and see if there's anything that can be canceled. All right, so number 2, again, we already have our common denominator set up for us, so that's always kind of nice. So now I'm just going to write 2x on the bottom. And then 3 minus 7, these are both like terms, so I can actually do that calculation, 3 minus 7, which would be -4. Now, this is an example of where I have 2 monomials here, so I can cancel parts of it if it simplifies. So like 4 over 2 is going to simplify to -2 over 1, and then I still have that x there. So my final answer would be -2 over x. All right, so now the third example, again, I have common denominators here. So on the bottom, I'm just going to have this x plus 1. But on the top, I have binomials here. And if they're being added, it wouldn't be as big of a deal, but it's being subtracted. So if you have 2x minus 1, and that is going to subtract your x plus 3, you have to remember that each of those numbers or terms is getting subtracted. So this is going to be minus x minus 3. And then you want to make sure if there's any like terms, you combine them. So 2x minus x is just going to give me an x. And then the -1 and the -3 will be a -4. So I end up with x minus 4 over x plus 1 as my final answer for that one. Now, you don't need to put the parentheses around those binomials. I just like to do it because if you remember from yesterday, when you're simplifying, reducing, and canceling, you can only cancel the entire binomial with another one that's exactly the same. So it helps me remember that it kind of stays together and they're not, you can't just cancel the x's. Like I couldn't cancel the x's and just have -4 over 1 for that problem. It has to, each of those binomials is its own term and has to stay. All right, so now when we move down to numbers 4 and 5, the denominators are not the same. So before you can figure out how to make them the same, sometimes it helps you if you factor it. So for example, like in the example that I showed you in the warm-up, right, 7 was just a 7, right? But 14 is really 7 times 2 if we think about it. So all we had to do was multiply the first fraction by 2. We didn't have to do 7 times 14, right? And that kept the numbers a little bit smaller and more manageable. So same thing here. If I factor this, because basically what I just did with this 14 here is I factored it into 7 and 2 so that I could see, all right, I have a common factor already, so I only have to multiply by that 2. So the same idea kind of occurs here. So the first thing I'm going to do is simplify whatever I can. So the 6x plus 1, I can't simplify that. There's no GCF, nothing I can do there. X squared minus 9, however, x squared minus 9 is a perfect square or difference of 2 perfect squares. So that can be factored into x plus 3 and x minus 3. So now, once my problem is set up and written in terms of factors versus like the more the product, I now see I already have a common factor. I already have an x minus 3 on each side. So all I need to do is multiply this side by the x plus 3. And now I have a common denominator, right? But whatever you do to the bottom, you do to the top. So if you think about it from terms of just normal ordinary numbers like we did in the beginning, I already had my 14 here, which is really 7 times 2. The other side just had the 7, so we multiplied both the top and the bottom by the 2. So it's the same kind of thing we're doing here. We're just multiplying by the x plus 3. So once we do that, I have my common denominator now, which is x plus 3, x minus 3. You only need it once you get it common on both sides. And then this numerator is going to be 6x plus 1 plus 4 times x plus 3. And I didn't have to worry about distributing just yet because that was a plus sign. But if you want to kind of distribute it as you write it, that's fine. Then I will just make this, just kind of save you some writing there, plus 4x plus 12. So now we're just going to simplify wherever we can. So on the top, we want to combine our like terms. I have a 6x and a 4x, which gives me a 10x. 1 plus 12 gives me 13. Then my denominator is still that least common denominator of x plus 3, x minus 3. And that would be my final answer. There's nothing that can be canceled there. I cannot further factor down anything with a GCF or anything like that. That's as far as I can go. Okay, so then let's look at number 5. Okay, so number 5, again, the first thing I'm going to do for number 5 is rewrite this, factoring out anything that I can factor. So my denominator on the first half here, I can factor this out into x and x. The two numbers that multiply to get 8 and subtract to get positive 2 are positive 4 minus 2. And then this side, I just have my 6 over my x plus 4. Okay, so now we can see that we already have a common factor on each side. We already have the x plus 4. But in order for me to make these least common denominators, the right side here still will need an x minus 2, and whatever you put on the bottom, you must also put on the top. So now when I go to do the subtraction, my denominator is just this least common denominator of x plus 4 and x minus 2. But my numerator is going to be 5x minus 1. And then since I'm subtracting, it's really going to be like a negative 6 times x minus 2, and I'm distributing that negative 6, right? So it's going to become negative 6x, and then negative 6 times negative 2 is positive 12. Sometimes people get a little confused when there's a subtraction there, and people forget that they have to distribute the negative with the number. Okay, so now we just want to simplify that numerator. So 5x minus 6x is going to give me a negative x. Negative 1 plus 12 is going to be a positive 11. And then my common denominator is x plus 4 and x minus 2. And that would be my answer there. Some people will factor out that negative, or if this is like a multiple choice or something, it might look like this instead. It doesn't help us cancel anything, but I just want you to realize it's the same answer in case you're dealing with multiple choices, and it's usually we don't leave a negative on the answer. We would factor that out. So it's the same answer. If it was an open-ended, I wouldn't care which way you wrote it, but if it's a multiple choice, it may only show up with that negative 1 factored out. Okay. So let's go on to the next page. We're basically just going to do a few more examples of this, but they're going to be a little bit more complex. So the denominators will require a little bit more work to get them to be common, right? All right, so doing the first example here, again, first thing I'm going to do is I'm going to rewrite the problem, factoring out anything that can be factored. Okay, so far the 10, the 2, the x minus 7, nothing I can do with any of those. So I'm going to factor out this trinomial here, x and x. The two numbers that multiply to get 14 and subtract to get negative 5 would be negative 7 and positive 2. So as we can see, we already have a common factor of x minus 7 on either fraction, but the first one also has the factor x plus 2, so I'm going to need to put that on this side as well. And whatever we do to the bottom, we have to do to the top. So now, since I have my common denominator on the bottom, I can add my two fractions. When you add the two fractions, you just put that least common denominator on the bottom once, and then we're going to do 10 plus, and we're going to distribute that 2 there, so plus 2x plus 4. Then if there's any simplifying that needs to happen, which here there definitely is, so we have 2x plus 14 over that common denominator. And then it looks like I can still take out a GCF on this top part. So if I take out a GCF of 2, I'm left with x plus 7, and then my common denominator is x minus 7, x plus 2. Now, on first glance, I was kind of thinking that maybe when I factored out that 2, I would have had x minus 7s to cancel or x plus 7s to cancel, but obviously they're different signs. So unfortunately, I can't cancel anything out. We got close to being able to, but not quite. Okay, so let's take a look at number 7. Now this time we have some monomials in here, and monomials are a little bit more like your traditional just adding and subtracting fractions. So usually what I do in this situation is if I'm trying to figure out, okay, what is my LCD here? I deal with the numbers first, right? So just look at the 4 and the 5 like you would have done back in elementary school. What is the LCD that I need for the 4 and the 5? So there's the only number that 4 and 5 both go into is 20. So I'm going to have to make these into 20s. Now, in addition to that, I also have an x squared and an x. So whenever you have two variables that are monomials, whatever one is bigger is going to be the least common denominator. So you're going to need each denominator here to be a 20x squared. So in order to make this 20x squared, what do I need to multiply the first fraction by? Well, the x squared is already there, but 4 needs to be multiplied by a 5. So I'm going to have to multiply the top and the bottom by 5. The second fraction, I need a 4 because 4 times 5 is 20, but I also need another x to make it 20x squared. And then whatever you do to the bottom, you're going to do on the top as well. So now let's see what we have. So on the top, I have 30, and then I have 20x squared on the bottom. And on the right-hand side, I have 8x, and then I have 20x squared on the bottom. So now when I add these, I have 20x squared on the bottom because that's my least common denominator. And then I just have my 8x plus 30. Now you could write 30 plus 8x, but typically standard form for algebraic answers is always working from your highest exponent and variable down to your constant at the end. So that's why I put it in that order. Now I can take out a GCF here of 2, I think, which will leave me with 4x plus 15, right? Now, it's important that we do that in this problem because you'll see that even though I can't do anything with my 4x plus 15 because that's a binomial and you would need an entire other 4x plus 15 to cancel it, it's all or nothing. Monomials, remember, you can just reduce them. So this 2 and this 20 can be reduced. So then this would end up just being 4x plus 15 on the top, and then that 20 would reduce to a 10x squared on the bottom. So that would be your final answer for that one. Okay, so now we're going to get to number 8 and number 9. So let's go to number 8. So now number 8, we have 3 terms. So when we're doing this one, let's take a look. All right, so first thing we need to do is figure out what is that least common denominator, right? So again, there's 3 types of things or parts that can be in your least common denominator. You can have just constants, You can have monomials, like your x squared, x cubed, those kinds of things. And then you can have these binomials, like this x minus 1. So basically right here, this x cubed is just 3x's being multiplied together, right? Then this middle term is 2x. So you have an x here. You also have a couple x's in the first one. So you're going to be able to kind of use those a little bit together. And then you have that 2. Now, first, this is what I do. I look at the constants first. The only constant I see in any of these is the 2. We're talking about a monomial constant. So I know I'm going to have 2 in my least common denominator. Then you want to look at all your monomial terms. So we have the x cubed and we have this x. So the least common denominator, what number do those both go into evenly? Well, whatever one's bigger. So it's going to be your x cubed. And then any binomial terms or factors have to also be included, but they're like a whole separate thing. You can't use the x that you already used from the x cubed as part of the x from the x minus 1 or anything like that. It has to be separate. So we need each of these denominators to become 2x to the third times x minus 1. So it's very annoying, right, that we have to write all this. And once you get the hang of it, you won't have to write it every time. You could just write it once as your common denominator. But just to kind of, I don't want to lose anybody, so I'm trying to break it down into steps. Okay. So now we got to figure out, well, what does each fraction need in order to look like this 2x cubed times x minus 1? So the first one, we already have the x cubed part of it, but we still need the 2 and the x minus 1, right? So we need to multiply it by 2, and we need to multiply it by x minus 1. So that will end up giving us 10 times x minus 1. Now the middle one, we already have the 2, and we have one of the x's, but we still need an x squared to get us to that x cubed, and we still need that binomial term of x minus 1. So this is going to become 4x squared times x minus 1. And then the third one, we have the x minus 1 part of the least common denominator, but we still need the 2x cubed. So you're going to multiply by 2x cubed, which is going to get you 6x cubed for that numerator. So now that we have all of these worked out, they're all changed to the least common denominator, we can now do the addition and subtraction. Now I'm only going to write my denominator once from now on, because that's the whole point. Once you're adding and subtracting fractions, you can just write your common denominator once. But now I'm going to have to add and subtract all these numerators. So I'm going to do the distributing while I do that. So the first one is going to become 10x minus 10. Then over here, just be careful because you have that negative. So this is really like negative 4x squared being distributed to each of these. So it's going to become negative 4x cubed plus 4x squared. And then you have your plus 6x cubed here at the end. So this one's kind of a little bit intense, right? So now we want to just combine any like terms, and I usually do this in order from greatest to least or whatnot. So I have 2 cubic terms. So I'm going to combine those. So that would give me 2x cubed. Then I have my plus 4x squared plus 10x minus 10. And that, of course, is all over this least common denominator. And then the last thing I want to do is see if there's any GCF or any factoring that can happen with that numerator. The denominator is obviously already factored. So it looks like it can divide out a 2 from everything. So if I divide out the 2, I'm left with x cubed plus 2x squared plus 5x minus 5. And that's over 2x cubed x minus 1. Now, because this GCF of 2 here can cancel out with that monomial right there, I believe the final answer for this one is this part here. And I'm just trying to take a quick peek if anything. Yeah, so sometimes you might be able to factor that top part some more using factoring by grouping, but I do not believe anything's going to factor out there. You'd take out, I'm just thinking out loud right here. If you took out the x squared, you'd be left with x plus 2, which would not match up with the other one. Yes, that's as far as you can go there. Okay, so that one was actually one of the hardest ones on this page, I think. 9 and 10 are going to kind of be a little bit easier, especially 9. But they can be a little challenging. You just need the practice finding those LCDs. All right, so let's take a look at number 9. So for number 9, again, first thing you want to do is find that LCD. So now the nice thing about this one is that the second half is already factored for us. So first thing we do is factor whatever's not factored. So this will be x plus 4, x minus 4. And then on this side, we have the x times x plus 4. All right, so now this one does have a common factor already. You have the x plus 4 on either side. So each fraction only needs to be multiplied by whatever it's missing. So like the one on the left is missing this x, so we need to multiply it by x. And the one on the right is missing the x minus 4, so that's what we have to multiply on that side. So let's see what we have now. So now we have our common denominator, which is x times x plus 4 times x minus 4. I only have to write it once. Then x times x is x squared. And then we have minus 5, which is going to get distributed to the x and the negative 4. So it'll be minus 5x and plus 20. Now, at this point, you might want to look at this trinomial and see if you can factor it some more. Are there any factors for 20 that add to get 5? If there were, then you would have to factor that into the two binomials and see if anything cancels, but it's not factorable any further. So thankfully, that's as far as we have to go for that one. All right, so let's take a look at 10 and 11. Okay, so for number 10, we have a monomial factor on this side. And then we have this binomial factor. However, there is a GCF that we can take out here. We can divide out a 3 and an x squared. So you always want to do that factoring first. Then you're left with 2x plus 1. Okay, so it's really important to do that first because now that we can see that, we see that we already have a 3 on both of these. And we have an x squared here, and this one we have an x cubed. So we only need an extra x on this side to match that 3x cubed, and then we need the 2x plus 1 on this side. Oops. So that we have the common denominator. So now your common denominator is going to be 3x cubed times 2x plus 1. So you have to be able to include all the factors. So now in the numerator, I have 8x plus 4, and then plus x squared. So I'm just going to write that in standard form. So remember, standard form is from the highest exponent working your way down. So it'd be x squared plus 8x plus 4 over 3x cubed times 2x plus 1. Now at that point, if you could factor that trinomial on the top, you would definitely want to do it, but there's no two numbers that multiply to get 4 and add up to get 8, so that's not factorable any further. And that would be your answer for number 10. Okay, and then finally we have number 11. So for number 11, okay, again, first thing I need to do is factor out this little piece here. So this is actually, let's see, this piece I could take out a GCF of 3, and then I'm left with x squared minus 1. So that one actually factors into 3 times x plus 1, x minus 1. Then I have plus 4 times x minus 1 plus 5 over the 6x. So let's figure out what that LCD is going to be. So my LCD, okay, we can see that we have a few different things here. So the first thing I see is that I'm looking at this actually here, I'll do it this way first. Okay. What do they have in common, first of all, right? So I do see that like this one and this one both have an x minus 1. So I know I'm going to need an x minus 1 over here, right? So now we got those three. They're all the same. Now, I see that the first one has a 3 and this one has a 6. So what would be my LCD there? 6. So I need to multiply this one by 2 and this one by 2. Or actually, no, this one needs to be multiplied by 6, sorry. And then I have an x on this problem. So I'm going to need an x here and also an x here. And then we got the x plus 1 on this one. So I need the x plus 1 on each of these. Now I have a feeling I lost a couple of you, so I'm going to try to go backtrack now. So the original LCDs here. Okay, so you've got these three, basically. Looking at just the constants first, I have a 3 and a 6 and basically a 1 in the middle. So 3, 6, and 1, what's the least common denominator? 6. So the denominator has to have a 6. Then I'm going to look at my monomial terms. The first one doesn't have any. The second one doesn't have any. The third one just has that single x. So I'm going to need to make sure I have an x on my denominators. My least common denominator has to include just that one x. Then binomial terms, I have both an x plus 1 and an x minus 1 that are going to be needed. So my least common denominator for each of the three fractions has to be 6x times x plus 1 times x minus 1. So whatever they're lacking needs to be multiplied to get it to that. So the first fraction, I need to multiply by a 2 and an x to get to the 6x. The middle one, I need the 6x and the x plus 1. And then the third one, I need both the x plus 1 and the x minus 1. And of course, whatever is done on the bottom needs to be done on the top as well. Okay, so then that's that. All right, so let's see what we have now. So we only have to write that LCD once on the bottom. We don't have to write it a million times. So 6x times x plus 1 times x minus 1. So now let's see what we ended up with on the top. So the first fraction I had to multiply by 2x. That's going to give me 20x squared. The second fraction, I can multiply these, which give me 24x times x plus 1. And then my third one, I have 5 times x plus 1, x minus 1. Now there's a lot of distributing and foiling that's going to have to happen now to combine all our like terms. So this problem is pretty ugly, but it is what it is. So on the top, I'm going to multiply everything out from this strip right here. So we're just doing a lot of foiling. So I have 20x squared plus 24x squared plus 24x. Now over here, I know that this part is going to actually work out to be x squared minus 1, and I'm going to distribute my 5 to that. So it's going to become 5x squared minus 5. And now, and that of course would be over my LCD. And now I want to combine like terms. So I have these x squares here, so I can combine all of those together. So that's going to be 44 plus 5, so 49x squared plus 24x minus 5. And that's going to go over that least common denominator of 6x, x plus 1, x minus 1. So this one is a pretty nasty problem, honestly. But that's what we can get it down into. All right. This is definitely the hardest lesson of this chapter. So, all right. So the last page is going over complex fractions. So basically, a complex fraction is just a fraction that contains a fraction. So what we want to do first is get rid of the fractions within the fraction. So if we just had x plus 4 over 8 plus whatever, it would look a lot easier. So we want to get rid of those denominators in the fraction itself. So, and I just highlighted the denominator that was in the top, and I highlighted the denominator that was in the bottom. So you're going to come up with the LCD from those. So it's 5 and x, so it's just going to be 5x. And you're going to distribute that to everything. And the reason why we're doing that is because it's going to get rid of these fractions within a fraction. So when I distribute my 5x here, right, on the top, I get 5x squared over 5. And then I would get plus 20x over nothing, right? Then on the bottom, I'm going to get 40x plus 5x over x. Now, this part you could probably do in your head once you get the hang of it. I'm just writing it out this time to show you what's happening. So those 5's will cancel. These x's will cancel. And so now you'll see that you no longer have fractions inside of a fraction. So now we just have x squared plus 20x on the top and 40x plus 5 on the bottom. And now we're just back to the beginning of yesterday's lesson where we factor and simplify. So for this one here, I would take out an x, and I'm left with x plus 20. On the bottom, I would take out a 5, and I'm left with 8x plus 1. And I think that's it. I think that's all I can do. Yeah, so it doesn't allow me to cancel anything. It just stops there. All right. So let's take a look at number 2. Just try to separate this so it's not a total mess. So my LCD for this one is going to be 2x, right? Because you can see these denominators that I got to get rid of. If I can get, anytime you have fractions in an equation that you want to get rid of, just multiply everything by those denominators and they cancel out. So if I multiply this by 2x and this by 2x, right? So on the top here, when I multiply 2x times x over 2, my 2's cancel. So I'm just left with x squared. And then 2x times negative 5 is negative 10x. On the bottom, 2x times 6 is 12x. And when I do 2x times 3 over x, the x's cancel, and I'm just left with 6. Now we're just factoring and canceling if it's possible. So in the numerator here, I can divide out an x. That's my GCF. On the bottom, I can take out a 6. Still doesn't help us cancel anything. So that's my answer for number 2. All right, so when we go to 3 and 4, it's the same process. We just have binomial factors that we may be distributing by. So again, look at all your denominators of those 3 fractions. Figure out what is the LCD going to be that you're going to multiply by. So here I have a 4 and an x plus 1. So basically, just like we did on the last couple pages, you're kind of just multiplying each fraction by whatever it needs. But rather than dealing with common denominators, we just want to get them to cancel out. So I'm going to multiply 4 times x plus 1. So when I do it on the top here, the x plus 1's cancel, and 4 times 20 is 80. When I do 4 times x plus 1 to my bottom here, on the first fraction, the 4's cancel, so I'm left with x plus 1. And on the second fraction, the x plus 1's cancel, and I'm left with minus 28. So then that just works out to be 80 over x minus 27. All right, so let's take a look at number 4. So first thing I want to do is, again, this needs to be factored so that you know really what you're looking at, so you can help kind of find your LCD. So this is 4 over Actually, I'm going to write it over here. 4 over x plus 3x minus 3. And then this one we know is 2 over x minus 3. And that's all over 1 over x plus 3 plus 1 over x minus 3. Okay, so now finding the LCD, since they're all binomials here, we know that we're just going to need an x plus 3 and an x minus 3 for each one. So that's what we're going to distribute to everything. So I'm going to distribute the x plus 3 and the x minus 3 to everything, and then it's just going to cancel out all those denominators so we don't have fractions in there anymore. So when you do it to the first one here, they totally cancel. You just have 4. When you do it to the second one, just the x minus 3's cancel. So you'd have 2 times x plus 3. When you do it on the bottom, this first fraction, the x plus 3's cancel. So you're left with x minus 3. When you do it to the second one, the x minus 3's cancel. So you're left with x plus 3. So now just to simplify that, so I have 4 plus 2x plus 6. I just distributed my 2. On the bottom, I have x minus 3 plus x plus 3. I don't have to worry about distributing anything. So now I'm combining like terms. I have 2x plus 10 on the top. And on the bottom, I have 2x because the 3's are going to cancel. And then if I take out a GCF on the top, 2 times x plus 5 over 2x. The 2's simplify, and my final answer is x plus 5 over x. So these are a little bit crazy. I'm sure some of you are not enjoying these. Okay, and then the last two. The last one in particular is not fun at all, but you can always stop the video if you're just about to explode by that point. Okay, so our LCD for number 5, you need a x and an x plus 2. So this one's not too bad. So we're going to multiply by both x and x plus 2. So when we do it to the first fraction here, the x plus 2's cancel. We're left with 2x. When you do it on the bottom, the first fraction, the x plus 2's cancel, so you're left with the x. On the second one, the x's cancel, so you would have 2 times x plus 2. So now on the bottom, you just want to distribute this, so it becomes 2x plus 4. And then I'm going to combine those like terms, so I get 3x plus 4 on the bottom, and that would be my answer for number 5. Okay, so the big problem here on the right. Okay, so first thing we're going to do is factor out these two so that we can really see what factors we're dealing with. So this first one, I take out a GCF, which would have me left with x squared minus 1, but you have to remember that that is actually x plus 1 and, whoops. I hate that happens. Okay. And then x minus 1. Now on the bottom, I have this 2 over x plus 1. And then on this one, I'm going to factor that. And the two numbers that multiply to get 3, that subtract to get the negative 2, or negative 3 and positive 1. So you can see that we already have this x plus 1 in common. But we have to make sure everything is included in that LCD to cancel everything out. So we're going to need a 2. We're going to need an x plus 1. We're going to also need an x minus 1, and we're going to need an x minus 3. So all of that, right? So when I multiply that entire thing to this numerator, the x plus 1's are going to cancel. The x minus 1s are going to cancel. The 2's are going to cancel, and I'm just left with x minus 3 getting multiplied to that 1, which is just x minus 3. Now, when I do this whole entire thing on the bottom, to the first fraction, the x plus 1's cancel, but everything else is still going to be there. So in that case, I'm going to have to do, 2 times 2, which is 4. And then I'm going to have x minus 1, x minus 3. When I go to the third one over here, the x minus 3 cancels, the x plus 1 cancels. So I'm left with 2 times x and x minus 1, like that. And now we want to simplify. So the numerator, we just have x minus 3. On the bottom here, I'm just going to try to do some foiling just to get that together here. So this is going to be 4 times x squared minus 4x plus 3. And then I'm going to distribute the 4 to all of that. So it becomes 4x squared minus 16x plus 12. Then on this part here, this is going to become plus 2x squared minus 2x. So I'm just going to continue simplifying that. So let's see if I have some room over here. So x minus 3 over, this is going to give me 6x squared. Then minus 18x plus 12. And I'm thinking, what else? Okay, so now I can take out a GCF there. And this is a crazy problem. Major extra credit type problem here, guys. X squared minus 3x plus 2. And you're going to love this even more. That's actually factorable. We'll keep that like that. So then that would actually work out to be the two numbers that multiply. It's 2 and 1 and minus and minus. And that would be your answer. Now, if you didn't factor that bottom part, it's not going to matter because you're not going to cancel anything anyway, but sometimes it's just impossible to know if you are without doing it. Okay, so this lesson definitely can utilize some practice as far as, the harder problems are concerned. You just need to know basically how to add and subtract fractions. Worry about the more simpler ones. Don't worry about if you can't do the last one I just did or the last one on the last page. Those are, definitely a higher intensity problem. But if you can do, like the first 4 without an issue, then I wouldn't stress too much about it. Again, I have meetup scheduled Tuesday, Wednesday, Thursday this week at 1:30 p.m. So hopefully that might be more convenient for some of you if you do have questions or you want to go over anything that we're doing in any of the lessons. Or you can always message me on Remind and ask me a question there. And Friday I'll go through a review as well. So hopefully that will help. All right. And don't forget to ask questions, and I will see you soon. Bye.